Alright, welcome back. In this video we're going to look at supporting functions and function calls, which look like this for a normal function call. Can also look like this when you have a language with first call functions, where get callback is a function that returns a function which you can then call. And function call precedence has kind of a is kind of high, so we put the function call like very low in the grammar, and right after unary. So let's look here. Or inside unary, and a call consists of a primary expression, which would be like the name, then a parenthesis, and some arguments, possibly some arguments, and then the closing parenthesis. And arguments is an expression, is an unlimited number of comma-separated expressions. So let's add an expression for that. Which we will add up here, so it keeps being alphabetically ordered. So we need a callee, which is the function name. It should be an expression. Then for some reason we want parentheses, and then we want the arguments, which should be a vector of expressions. So far so good. And now let's update the parser. Okay, it stores the token for the closing parenthesis. We'll use that token as location when we report runtime error caused by a function call. That makes a lot of sense. Crack open the parser, where unary expected to jump straight to primary, change it to call instead. Oops. So right here should be call, and call should have the same signature as always. And we have to try to get the function name. And then he has this fun structure. Where really we could have said while self.match token left parens, or something like that. Or if self.match token left paren. But he says here that the reason we do that is it'll make sense when we expand the parser later to handle properties on objects. Because then you could have a primary expression, I guess, and then like a dot operator, something like that. So let's implement this finish call, which takes mutable self, and it also takes the callee, and it should return result of an expr or a string. So arguments, is something that we have to mutate, and we'll say if not, meaning we should find some arguments. And then do we have do while in Rust? And it seems we don't, but we can do something like this. And let's say, let's call it arg, which should be an expression. And then we will push that to arguments. And then we will say, if not, if we don't have a comma, then we break out of the loop. And it should end. And then we can, so let me see here, consume. Okay. It should end with a right paren. And then we can finally return a call with callee and parent and arguments. And it should be wrapped in OK. Let's check that. And it also wants us to use the loop here. So let's do that. And there's a problem in the... it's because this has to be OK. And this has to be boxed. Okay, and now we get some errors in Expa and probably other places. Maybe not. Let me see, this one shouldn't happen. Because we have to mark it as mutable. Okay, so now we get errors from these match clauses that we have, that they don't cover call. So let's go do that. We need to cover it here as well. So callee and arguments. We can say it's just the function name and then the arguments. I guess. And the arguments, they have to be formatted with the debug formatter because it's a vector. And then we go down here, we need to, this is completely randomly ordered. Okay, the binary one is very horrible. Maybe we should fix that at some point. Just gonna randomly add it here. Okay. So what do we do here when we want to call the function? Let's add that here because I guess we would have to, we can make some notes. Look up function definition in environment. apply to arguments. Like do some checking. For example, number of arguments. So, but we don't really support having function definitions yet. So let's see what happens next in the book. Okay, maximum arguments counts. Right now the loop where we pass arguments has no bound. If you want to call a function, pass a million arguments to it, the parser would have no problem with it. Do we want to limit that? So here he says that it's good to add a limit, especially when we make the bytecode interpreter later. So let's go and do that. And I guess we can do it here. So if arguments length is greater than equals to 255, then we will return an error and have more than 255 arguments. And really it could also return like the token, or let's say just a location, which line number, I think. And then we can write line location that's one too many. Right, now it's just complaining about unused fields, which is fine for now. But actually, let's go fix the one up here. Okay. Yeah, we don't have any functions we can call. Functions are not really implemented. So it seems weird to start implementing calls first, but we'll worry about that later. As always, interpretation starts with a new visit. So this is a little bit, here he will later define an object called a logs callable, I guess. And that will be some kind of type that has the function definition and the, it has this function called call, and but we don't have that. We could define a type. I kind of would like it in the environment, but the environment is just literal values, so then it could become, function could become a literal value. I guess that's what you talk about when you say first class functions. Okay, so I think he's using this lux callable interface thing, but we don't have something quite similar. I mean, maybe traits could be used, but I think a simpler way to go about it is to make a new type called callable, which needs to hold yeah, you need to be able to call it. So not sure how we will do that. That is interesting. But at least we need the arity, like how many inputs can it take? And let's leave it there for now. Maybe it could get a name as well, but let's leave it like that. You know what, let's give it a name too. And then here when we implement callable to string, it can just be a name, arity. Then we can actually do like a Erlang kind of thing, where we say it's the name slash the arity. Arity. And we need to type that's good enough. This one we also need is a callable a truthy value. I think for now we will just say cannot use callable as a truthy value. And the same up here. And now, when we try to evaluate a function call, then let's first get the call, something that should be a callable. So we will say, give me the callee and evaluate that on the environment. And now let's match the callable with a callable expression, a callable literal value rather, and it has the name, it has the arity, and that will be to do. And anything else we will return an error that says maybe to type. Did we have that? Yes, to type. So we will say other to type is not callable. And then like this. See if it more or less compiles. Mm, 93. Strict variant color is imported here. I don't get it. I don't. Because we have to say name arity and the same down here in truthy. And again, and more warnings to 18. And I will just ignore these for now, even though we are definitely going to use them later. And it's never constructed, but it should be soon. Okay, let's see what happens next. Okay, call type errors, totally not a function. So strings are uncallable in logs. We already, if callee is not instance of logs callable through runtime error. So, yeah, how do we handle classes or like objects? Because they should also be a callable. So perhaps it's wrong to do this. Maybe we should do something called, I don't know, objects. And then functions are also objects, like in Python. I guess we'll think about that later. I think it will make more sense when we do the function definition code. But anyway, so if it's not a callable, then you throw an error. I do the same here. Then you check arity. So we can do that. Now we actually do need the arguments. We do need the arity and probably the name as well. So if arguments.length is not equal to arity, then we return an error. And we will say func, or rather callable something, expected so many arguments, but got so many arguments. And then name, arity, and arguments.length. Oops. Okay, this can be a use size. I don't really mind that. Shouldn't be negative in any case, so I guess it makes sense. Great. So now we also check for arity. different languages take different approach to this problem. Of course, more statically typed, check at compile time. JavaScript discards extra arguments. So yeah, we just raise an error. I think that makes a lot of sense. Okay. Then there's also a concept of native functions. Just gonna skip that. So now we will change the interpreter to also have a set of globals. Now I'm not sure if that needs to be in a ref cell like the environment, so let's just make it an environment for now. And then he wants to define this clock function as like a built-in function. So let's do that. When we instantiate, we'll say globals is this. It should be mutable, because then I want to... Okay, now what? Now what? Because now I want to push a callable. What is an environment? Not that. What is an environment, please? It has literal values, so that's okay. So anyway, push a callable with the name clock to string. And an arity of 0. And then like interesting. Actually, it should be lowercase. Not really gonna think about that. Okay, but fine, now we have a callable, but it doesn't, we don't know how to use it. So let me look something up. So one thing I've tried is to make this literal value generic, so it can take any type. You know, the callable can take any type as long as that type is a function that takes a literal value and returns a literal value. Actually, it should be a vector of literal values, but the problem is the same, which is that these generic type parameters are gonna propagate all over the place. So I don't want to do it like that. Okay, here is my next try. We'll see if that works. So I want to use this function type, but this is a trait, so we need to use the dynamic keyword so that it's like specifying that this can be anything. It's not a specific type, it's dynamically determined what the type is. But then you cannot just put that into a function because it doesn't have a known size, so I need to put it inside a pointer. Now normally I would use box, but then the problem is that you cannot clone a box. And just to make things easier, I'm going to use RC, so we have that this thing can be owned by multiple places in the code, but only in an immutable way. This is a thing we learned a few few videos ago, that RC is for shared memory, but only shared immutable memory. Okay, so now we just get some things here. And also I had to remove debug and partial eq from here, because it doesn't know how to debug print a function, and also doesn't know how to equate functions. So that kind of sucks, but we'll see if it gives any problems. I'm not sure we used it. So we don't need the function here. We don't need it here. And let's see, line 99. Also, don't need it there. 134. Same thing. And 143. Now we cannot debug print expression anymore, which is great. And 197. Let me see. Expression. Damn. So then we need to implement it ourselves. I guess it's like this. Let me look. Okay, so it looks like that. And we need to use std fmt implement format std format formatter. Not gonna think too much about why it looks like this. This is gonna be really annoying. You know what, we have the toString, right? So why don't we just call that? Then maybe we don't need this. The origin is the point. We can also just say write and then self toString. Format argument must be string literal. Okay. Now we get this problem that we need the eq. So let's look. It looks like this. So I want to match self and other with like number X, number Y, and then I want to return X equals Y. And the interesting thing is, what if we get two callables, name, arity, and function, which I'm not gonna use, and callable name, name2, arity, arity2, and function not gonna use. And that should return name equals name2 and arity equals arity2. And like for better idea, Lure for better idea, let's try this. And now it's also complaining about the formatting, so we'll have to implement that. But anyway, this definition is not complete, so I'll just add the other fields. So here's the full definition. I match on the types. If it's the same type, we compare the values. And if it's anything else, we just return false. So now let's fix some of the errors. So 387, we need the debug implementation. So we need to do this, but for literal value. It's beginning to be where this literal value needs its own file. It's just too big. And yeah, I mean, it's just the same, right? Okay. Now that we have that, it seems we can go back and try to get this thing to work. Okay, so it's not called push. I don't know why I thought of it as a vector. It is called define. Maybe we don't. Whatever. So define and call clock, and it does have to be a string. Does have to be a string. Which is a little bit annoying, but okay. Let's see. That will not run because it needs the function. Okay. It needs to be an RC to something that has this signature. So I'm just gonna put it here for now, because probably we want like this quote unquote standard library to be in a different file. But anyway, so it needs to have, it's a little bit unfortunate that it has to have this signature. But okay. All right, so now we need to figure out how to get the time, the system time in Rust. And we can probably use this. It has a function called now. It returns a system time object. So we can say now equals std time system time now. And what can this guy do? Like, can we get it in seconds or something, please? What is it, this instant? Something else. Is not monotonic. That means you can save a file to the file system. Okay, so let's not. That sounds a little bit weird. So let's instead use instant. Which is monotonic. Probably at the end of the day it won't matter that much. Why won't it show me that it has this method? I don't get it, but whatever. Let's return the seconds. And then we want to wrap that in a number, I think it's called. Let's then make an RC that points to this clock implementation. Hope it works. Method not found in instant. We need this. But this elapsed is a little bit weird. Since this instance was created, that's not what I want. I want just the system time right now. Again, there's just this elapsed. This is highly annoying. Okay, so evidently we're supposed to use it kind of like this. So we make a now and then we say duration since Unix epoch. Then let's try that. And we do this. And it's not direction, it's duration. And let's kind of unwrap it. Could not get system time. can we say as millisecs? Let's just call millis. And then I want to convert this to F32 divided by 1000. So it's in seconds. And this one is unused, which is intentional. Okay, that worked. Very cool. But this field is never used, that's fine. Let's keep going. So now we actually managed to define a global function. I wonder if, okay, so we need to also so how do we do this? Because we need to look up things in the environment too, in the globals at appropriate times. I mean, really, this globals could just be this environment, so we don't need two separate things. That would make things a lot easier, and I think we could already use it now. Let's try that for a second. Let me do that. And that. And this. See if it compiles. It compiled. Let's try to run it. And now if I say clock, it panicked. Expression 299. Ah, right. So then we simply want to say, we have the function. Then we can call it with the arguments. And I think I want this to be a reference. You think we can do that? Expected struct. Don't really get what just happened. $298. It will do something, return a value, and then we return that value. Why does it say it expected a struct? So what if I do this? Huh. Arguments to this function are incorrect. Because the arguments, let me see here, is a list of expressions, so we need to evaluate all the expressions first. So let's say evaluate arguments, and is there like a nice way to do that? Not really. So we're gonna say I'm gonna shadow it and say arguments. We map the arc to arc.evaluate, and it needs the environment. And can we do this? And then we collect them. And then we apply them. Yeah. Then we need to iterate it. No, not there. We need to iterate it. Cannot use operator and closure that returns literal value. So this would be a lot easier in Haskell. Let's say, let's call it argvals, and it's going to be a mutable vector. And then we simply say for arg and arguments, let value equal to arg.evaluate on this environment, cloned of course. Now we can short circuit if something goes wrong. We push it and then we use it down here. Expected reference from struct. Yeah, great. Now we need to update this code. Fantastic. Now let's try to say clock. Let's say A equals clock. Print A. You can also, I don't think it's correct, but we should also be able to do this. And it is giving the same thing all the time. At least we have some kind of framework where we can actually define functions and call them in a reasonably nice way. And I'm gonna keep it like this for now, where the globals are just like the first environment, which makes sense. It means that well, let me see what happens when we assign a variable and we call define on that environment. Define simply inserts. So this, it means that we can override clock, the clock function, which is, or any other globally defined function or value, but I guess that's fine. I mean, we can think about adding namespacing later or something like that. But for now, let's say that's fine. But let's try to fix this very annoying thing. Wonder why. This happens. This is going to be a little bit weird, but let's just return. Let me first comment this out so I don't forget that I need to do that. And then we make it into a string instead. And we will say, it's just now. Let's try to run that. It's called string value. And then we can print clock. And it's very annoying, there's no. So it is working, it's just because we lose some precision when we convert it to F62. So let's try just returning it as seconds. no, it's still not good enough. What if we make this into a 64 thing, 64-bit? And that is easier said than done. Where does it complain? It complains in Expo, so we can go through and replace F32 with F64. Yeah, fine. Let's try that. Now that was sufficient. So let's keep it as an F64. Great, and I mean, probably we want milliseconds. So we get a little bit more precision for time measurement. Okay, I think we will leave it here for this video, which is already like crazy long. But we implemented functions. Now I'm not sure we have done it in the optimal way. Especially because when it comes to implementing objects, we may have to change this to look completely different. But I guess we'll deal with that when the time comes. Okay, see you in the next video.